More than 15 billion miles from Earth, in a region of space so distant that sunlight is barely distinguishable from the background glow of the galaxy, a signal arrived at NASA's Deep Space Network. It had been traveling for over 20 hours across interplanetary space, past the outer planets, beyond the edge of the sun's influence. And by the time it reached Earth, the signal was almost impossibly weak. Less energy than the power used by a watch battery. Yet engineers were still listening, because the signal came from Voyager, the most distant spacecraft humanity has ever built. For nearly half a century, Voyager has been drifting farther and farther away from the sun, sending faint streams of data back to Earth. Most of the time, those transmissions are predictable. Instrument status, cosmic ray counts, magnetic field readings from the space between stars. But recently, something unusual appeared in the data. Not a dramatic alarm, not a sudden spike, just a pattern. Small fluctuations in the energetic particles surrounding the spacecraft. At first glance, the readings looked like noise. Voyager is old, very old. Its onboard computer was designed in the 1970s, with less processing power than a modern calculator. Signals traveling billions of miles across space are fragile. Radiation distorts them. Data packets arrive incomplete. Entire fragments of information can vanish before they ever reach Earth. NASA engineers are used to this. Reconstructing Voyager's transmissions has become a kind of digital archaeology. Each signal must be decoded, corrected, and rebuilt from scattered fragments before scientists can analyze what the spacecraft actually recorded. And that was exactly what engineers were doing when they noticed something strange. Even after reconstruction, the pattern didn't disappear. The readings were consistent. Voyager had passed through something, and the disturbance looked strangely familiar. Because in planetary science, when a spacecraft flies near a massive object, the environment around it changes. Charged particles bend, magnetic fields distort, plasma density rises and falls. Even if the spacecraft never sees the object itself, the surrounding space reacts to its presence. Voyager, however, cannot see anything anymore. Its cameras were permanently shut down in 1990. The famous photograph known as the pale blue dot, the tiny image of Earth taken from the edge of the solar system, was the last picture Voyager ever captured. After that, NASA turned off the cameras to conserve power for the long journey ahead. From that moment forward, Voyager would explore the universe without eyes. Instead, it would rely on instruments designed to measure invisible forces. Magnetic fields, cosmic radiation, charged particles drifting through space, plasma waves moving through the interstellar medium. These measurements may not produce photographs, but they create something equally valuable, a map of the invisible environment surrounding the spacecraft. And sometimes, when something massive exists nearby, those invisible forces shift. Which is exactly what Voyager's instruments appeared to be recording. When scientists plotted the reconstructed data, they noticed a gradual increase in energetic particles, then a shift, then a slow return to normal levels. The pattern repeated across multiple transmissions, almost like Voyager had crossed the boundary of a region where space itself behaved differently. The first explanation scientists considered was a common one: interstellar shock waves. These are disturbances created when stellar winds collide with the interstellar medium. They can produce sudden changes in particle density and magnetic field strength. But the Voyager data did not match the typical structure of a shock wave. Shock waves produce sharp spikes. Voyager's readings were smoother, gradual, structured. The second possibility involved plasma clouds, regions of slightly denser material drifting between stars. But those tend to produce broad disturbances lasting thousands of kilometers. Voyager's readings suggested something smaller, localized, contained. And that possibility raised an intriguing question. What if the disturbance wasn't caused by a cloud, but by an object? Because large objects, even invisible ones, leave fingerprints in space. Their gravity shapes the movement of charged particles. Their magnetic fields bend plasma currents. Their presence subtly alters the environment around them. And if Voyager had passed near such an object, its instruments might detect those changes, even billions of miles from Earth. Now here's the part that makes this possibility particularly fascinating. By the time Voyager recorded these measurements, the spacecraft was no longer inside our solar system. Back in 2012, Voyager crossed the heliopause. This is the boundary where the sun's solar wind finally loses its influence and the interstellar medium begins. Beyond that point lies true interstellar space, a region humanity had never explored before Voyager arrived. Every measurement the spacecraft sends now comes from a place no probe had ever visited, which means scientists have no complete model of what to expect. And that uncertainty makes every unusual reading important, because sometimes those readings reveal something entirely new. One explanation scientists began discussing was something astronomers have only recently started to appreciate: the existence of rogue planets. Unlike planets in our solar system, rogue planets do not orbit a star. They wander through the galaxy alone. Astronomers believe many of them formed around young stars before being violently ejected by gravitational interactions early in their system's history. Once expelled, they drift into the darkness between stars. Cold, invisible, almost impossible to detect. Recent studies suggest there may be billions of rogue planets in the Milky Way, possibly even more than there are stars, but detecting them is extremely difficult. Without a star to illuminate them, these worlds emit almost no light. Most can only be found indirectly when their gravity briefly bends the light of a distant star in an event known as gravitational microlensing. But Voyager might have encountered one in a completely different way, not through light, not through photography, but through the disturbance it created in the surrounding space. When a massive object moves through the interstellar medium, it interacts with the particles around it. Its gravity and magnetic environment reshape the flow of charged particles. That disturbance can sometimes be detected by instruments like those aboard Voyager, which is exactly what the spacecraft's particle detectors appeared to be recording: a localized disturbance, a boundary crossing, a brief interaction with something that subtly influenced the environment around the spacecraft. Now, scientists are cautious. Interstellar space is still full of poorly understood phenomena: magnetic turbulence, plasma instabilities, shock fronts produced by distant stellar events. Any of these could potentially produce unusual readings. But the structure in Voyager's data remains intriguing, because the pattern persisted across multiple transmissions, meaning this was not just a random glitch. It was something Voyager experienced over time, something that affected the space around it long enough for the spacecraft to measure. And that possibility has sparked quiet discussion among researchers analyzing the data. Because if Voyager truly passed near a rogue planet, it would represent something extraordinary. It would be the first time a human-made spacecraft had encountered a world drifting between the stars. Not in orbit around a sun, not part of any solar system, but alone, moving silently through interstellar darkness. And the only evidence we would have would be hidden inside a few fragile packets of data transmitted across 15 billion miles of space. For now, the mystery remains unresolved. Voyager continues its slow journey outward. Traveling roughly 38,000 miles per hour, the spacecraft drifts deeper into interstellar space every day. Its power supply slowly fades. Each year, NASA engineers shut down another instrument to conserve energy. Eventually, Voyager will fall silent. Its final signal will fade into the background noise of the cosmos, and the spacecraft will continue its journey alone for millions of years. But until that moment arrives, Voyager is still listening, still measuring, still sending faint whispers of data from a place humanity has never been. And sometimes, hidden inside those whispers, scientists find clues that suggest the darkness between stars may not be as empty as we once believed. Because somewhere out there, in the vast interstellar ocean, Voyager is now crossing. There may be worlds drifting unseen, and one of them may have just left its fingerprints on humanity's most distant explorer.